Consider an aspiring writer who writes a single line on day 1 and plans to double the number of lines she writes each day for a month. About how many lines would she write at the end of the month on the 30th day? So let's see, what I'm going to do here is I'm just going to start by listing the number of days. There's day 1, day 2, day 3, day 4, day 5, and that's going to continue on. And then the number of lines she writes each day. So the first day she's going to write 1 line, then 2 lines, then 4 lines, then 8 lines, then 16 lines, and so on. So if you're doubling each day, it's going to be some type of an exponential model, which means it could be f of x equals 2 to the x or something like that. So let's try and match these numbers with that function pattern. Well, let's look at the exponents of 2. For day 1, she writes 1 line, so that's 2 to the 0 power is 1. Then the next day she writes 2 lines, or 2 to the 1 power. The next day is 2 to the 2nd power, or 4. The next day is 2 to the 3rd power, and then 2 to the 4th power, and so on and so forth. So how does this translate into our model? Well, if you notice here, the exponent is 1 less than the input value x here. So this is x, this is f of x. So that means our model is f of x equals 2 to the x minus 1. So to answer the question, on the 30th day, we're going to do f of 30 equals 2 to the 30 minus 1 power, which is 2 to the 29th power. So let's go to the calculator. 2 to the 29th power. Okay, so that looks like 536,870,912. I'm just going to round that to 537 million. Okay, so according to the model, that is how many lines she would write at the end of the month on the 30th day. So there might be some type of limitation here on the number of lines she can write in a day. She can double for a while, but then eventually it just becomes too many and the model won't work anymore.